Hey, good morning, Algebra. Glad you're here. Make sure your phone is wrapped up, zipped up in your bag. Make sure your ID is on your body. We're going to look at 1.5 and 1.6 today. Just kind of knock out some fast stuff. I will give you some information on how you can, where I would suggest you go to get more background on some of the review that's here. Um, we're going to go some basic things like what are x and y intercepts. We're going to look at linear functions, slope, y equals mx plus b, point slope, slope intercept, all those things. I'm going to rip pretty fast through them. You may want more background and more review. I will show you what I feel is an excellent place to get that, and you can moderate that as much or as little as you need. We'll look at both with and without calculators today. And so if you don't have a graphing calculator at your desk, you may want to grab one from up front. If you don't have a graphing calculator, I don't need you to go buy one. I do think you need to go buy some AAA batteries. Okay, we've got you covered on the hardware. The least you could do is pick up the batteries you need. They're AAA. You need 4 of them. If you would bring those, that would make sure that you have a calculator when we do need to do graphing that is reasonable. I know that I asked you to put your phone away, but the other thing you might consider today is appropriately using your phone to graph on Desmos online in order to get some better support of what we're talking about. But what I don't, need to have somebody babysit and monitor is you texting or messaging or on social media. All right, so I'm trusting you to be able to handle that. In 1.5, the focus is graph and graphing utilities, and we've already defined what a graph is. It's a visual list of all solutions, and when you have 2 variables in an equation, there's an infinite number of solutions. That's why you see t-charts and keep picking another value, plugging it in, get another y value out, plot a point, pick another value, plug it in, get a y value out, plot a point. That could literally go on forever. And so on the coordinate system, we make a graph. A graph is a visual listing of all the solutions. We put arrows at the ends of those trends that show where things continue on in the same pattern. And so one of the most important things that we need to be able to do is figure out x and y intercepts. All right, so x and y intercepts are on the table today. They are the places, if we're thinking visually, about where we cross the axes with a graph, our visual list of all solutions. Wherever we cross the x-axis, we would call it an x-intercept. Wherever we cross the y-axis, we'd call it a y-intercept. But the best way for you to think about these is not from the visual perspective, but from the numerical perspective. If I want an x-intercept, I got to find the value of x when y is 0. That's the definition you should know for x-intercepts. It's the value of x when y is 0. Whatever intercept you're looking for, you make the other one become 0. So if I want to find a y-intercept, I make the x become 0. And this is the best way for you to remember the definition of intercepts. So find the x and y intercepts of the following function right here. Y equals x squared minus 4x minus 12 algebraically. That means with your pencil and your paper, and you grinding out what you need to grind out. The way you're going to handle that, if you want to find the x-intercepts, you're going to have to make the y become what? 0, correct? So when you make the y become 0, you're probably going to be able to solve by factoring. Okay? So when I let the x equal 0 or the y equal 0, the value of x when y equals 0, the value of y-intercept, the value of y when x equals 0. When I set that thing equal to 0, I can probably solve this by factoring. I could probably solve it by the quadratic formula. I could certainly solve it by mode 5.3 on my calculator. Any of those would be legitimate unless you didn't have a calculator to use. So it's a negative number. They got to be different signs. Signs got to be different. They got to be adding up to -4. I'm thinking 6 and 2 are probably legitimate values for those magic numbers in the factoring process. Once you make y 0, you're down to a one variable equation. You use one variable equation techniques in order to solve it. And that means you set each factor equal to 0. X minus 6 equals 0, x plus 2 equals 0. You get the two values of x. When you're done with that, okay, I want you to write ordered pairs. And we ask you for intercepts. We start by letting y equals 0. We solve this in this case by factoring or whatever tool is needed. And then once we find those two critical numbers there, what the x is, 6 and -2, and we put them right back into ordered pairs and express our answer as ordered pairs. Does that make sense? So those are not the only intercepts this thing has. There's also a y-intercept. It's the value of y when x is 0. So we will take and not set the x is equal to 0. We'll set the y equal to 0. I'm sorry, we'll set the x equal to 0 when we're trying to find the y-intercept. Okay? There's our function. And we're going to plug 0 in for each of the x's. If we plug 0 in for each of the x's, we figure out that, hey, things drop out quickly. And when things drop out quickly, we get y equals -12. And we get y equals -12. We don't just stop. We go back and we write it as an ordered pair. We put 0 in for x. We solve for y. If this thing is set up in function notation, those terms, all the terms with the constant will drop out as soon as we plug a 0 in. And then we write the ordered pair as 0, -12. So when we look back, we have 3 intercepts. If somebody said find the intercepts and didn't specify x and y, we would check for both of those to make sure that we have them. Does that make sense? Okay. Next one. Find the x and y intercepts using the calculator. All right, so this would be a good place for you to pull up your graphing calculator from the front. Borrow one from me. This is Algebra 2 review for most of you. If you had, most of the teachers would have taught you how to find the x-intercepts. I'm going to take a look at it in an easier format here, which is on Desmos. Okay, Desmos is an online graphing calculator. Here's the function y equals x cubed plus x squared minus 3x. The thing I like about Desmos is I don't have to worry about what window I'm in. You know, did I get the 10 to 10 window? Did I get it all set up? Because Desmos is going to automatically bring that stuff for me to where it should be. Okay, but if I'm looking on a calculator, I should be in kind of that -10 on the x, -10 to 10 on the x's, and -10 to 10 on the y's. I should see a function that's cubic in nature because the degree is 3. But as soon as I touch the function in Desmos, I can see those points where it crosses the x-axis, those points where it crosses the y-axis. So -2.303 is an estimate. I'm sure it's a cube root. It's probably irrational. And 1.303 and 0. These are our 3 values of the x-intercept. -2.303, 1.303, and 0. It also happens to be the value of the y-intercept is 0, 0. The other thing about Desmos is nice that it identifies minimums and maximums for you automatically without having to go through all the steps on the calculator. Okay? If you were to put it in your Casio, you'd probably go to the GSolve menu and you go to the root and hit your right arrow, and you'd be able to see all of those as well. Again, I hope that's review. We can kind of go back over that when I get in for those of you that need more. But there's how we would find the x and y intercepts graphically using graphing. You try another one there. 2x squared plus x equals -5. If I put the 0 in for the x's, I can immediately see what my y-intercept is. It's 0 for x and -5 for y, because this term drops off and that term drops off, and I get y equals -5. So that's straightforward. If I wanted to find the x-intercepts, well, without a calculator, I would probably have to go into checking for factorability. I can tell from these roots that it didn't. 2 times -5 is -10. No factors of 10 that add up to be 1 when you subtract two numbers. And so then I would have to bust into the quadratic formula if I was going to solve it without the calculator. If I solve it without the calculator, then I would break it into x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I would crank that in the way I have for a couple of different math classes now. Reviewed it already. Of course, I'm going to run out of room there. Let's slide that over to A. And I'd plug in my values. A is 2, B is 1. C is -5. If you listened to me the other day, you know this is the place where the majority of the mistakes get made. That's a positive sign, two negatives. I've got 4 times 2 times 5, which is, I believe, 40. And then I square the 1 to get 1. I end up with 41 in my radical. It's irreducible. It's irreducible. I cannot simplify it out. And that's all over 4. And if you punch those values in the calculator, you should get the two values of x that are listed up there. -1.851 and 1.351. So x and y intercepts are fairly critical. Let's look at that in Desmos real fast. 2x squared plus x minus 5. I don't know if Desmos is going to work for me when I do it like this. Okay. I think that was 2x. That's going to be real challenging. So maybe we won't do that in Desmos right now. Wait, let's get the Desmos calculator up. 2x squared plus x minus 5. We can beat this thing. Plus x minus 5. Let's see our two x-intercepts. Let's see our y-intercept. And you know why I think Desmos is such a powerful bit of software. This is the same calculator they use on the AZ Merit embedded in there. It's a free graphing utility online. It's just not great for test taking because obviously it's an online environment. Okay. Scroll back to a couple more. 8x cubed minus 6x minus 1. Try plugging that into either your Casio or onto your online, and you should get, well, certainly you should get the x's dropping out for a y-intercept of -1. And you would expect to see 3 different x-intercepts on the graph. Okay? Sometimes we don't have x-intercepts. Sometimes when we look at a function like this, We have a y-intercept that's there, but there are no x-intercepts because it's been shifted up and it's opening up, or it's been shifted down and it's opening down. So if we tried to run this through the quadratic formula, we would get imaginary roots. So just kind of a quick thing to go back over x and y intercepts so that you're kind of reacquainted with that concept out of 1.5. And then we'll go on to 1.6. 1.6 is a review of lines and linear functions. And if you're unfamiliar with any of these, you're going to need to reacquaint yourself with them. They're kind of the basis of all of what we do. We showed you why the triangle and the rise and the run was essential to sine waves and how that tied into virtually everything yesterday. So it all starts with the green there and slope. And then we look at lines with consistent slopes. We know there are 3 different ways we could express them. Slope-intercept form, point-slope form, and standard form. Okay? And you have to pay attention as to whether or not we're working with standard form, particularly in multiple choice situations, where you have the C over on the right-hand expression, or whether you have the C moved over to the left-hand expression. Okay, things we're supposed to know. A, B, and C cannot be fractions of decimals. They're going to have to be whole numbers in standard form. We prefer it's rearranged so that the A is a positive whole number. Don't care about B or C. Can't control those, but I can rearrange until A is positive in the way I manipulate things. So these should be things that are like second nature to you by now. If they're not, I'm going to show you Mr. Taru's Chalk Talk link later. I suggest you search it up and you watch everything in his video description. It will review everything you're supposed to know from Algebra 1 and Algebra 2 about lines. 2 other special lines are the horizontal line. It has a slope of 0. It looks just like y equals 2. And a vertical line like x equals 3. Of course, the numbers can be anything that moves them on the coordinate system, but you need to know that a horizontal line has a slope of 0. That's why its m drops off, and you just have the y equals b. And a vertical line has an infinitely large slope. The more vertical you get, the larger the rise is compared to the run. And when you're at vertical, there's an infinite amount of rise for no run, and you're dividing by 0 on that slope calculation. That's why we say it's undefined. Small slopes are flat, and large slopes are steep. Slope is a measure of steepness. Okay? So find the equation of a horizontal line. Horizontal line, which one was that? Go back and look. Is it y equals mx plus b? Is it point slope? Is it standard form? Is it slope? Or is it the ones we were just talking about down here? Y equals a horizontal line. So if you want the horizontal line, you want the y value that is in the ordered pair and make it go through that point. Y equals -2. It's a horizontal line. You can think about the guy running across the horizon. Does it go through the point 4, -2? Yes, it does. And like I said, horizontal lines are perfectly flat. There is no steepness, and so their slope value is 0. Like the equation of the vertical line. Vertical line, oh, that wasn't the y equals. It was the x equals. Vertical line is x equals a number. The slope is infinitely large and undefined. So when you ask me to find the equation of a vertical line, I need the x values, not the y values. And I would say that it's x equals 7. All the ordered pairs on this line go through an x value like 7, -1, 7, -2, 7, -3, 7, 6, 7, 8, 7, 20, 7, 54. All those have x values of 7. That's why it should be very easy to remember that on a vertical line, it's x equals the number. The slope is infinitely large and therefore is undefined. We can say it has no slope. I prefer you say it's undefined. Write the equation of the line whose x-intercept. Oh, you learned about that in the last. You mean the value of x when y is 0? That must be 8 comma 0, correct? And the y-intercept is, oh, you mean the value of y when x is 0, 0 comma negative 2. These are two ordered pairs that have been given to us. They didn't start out like going, hey, I'm an ordered pair, look at me, but they are ordered pairs that were given to you. And so with that, your next move is to go back and think, what can I do with two ordered pairs? Well, can I write slope-intercept form? Probably not. Can I write point-slope form? No, because I'd need not just one point, I'd also need a slope. But if I have two ordered pairs, x1, y1, x2, y2, can I find slope? Yes. And if I find slope, can I take a point and a slope and use point-slope form to write a line? And then can I rearrange it in slope-intercept form? Yes, I can. Do I need to know all those forms? Yes, I do. So, f equals y2 minus y1 over x2 minus x1. I don't care which point you call 1 or 2, but it's not a bad idea if you're in Algebra 1 to write them down underneath it so you don't get confused. You might look at this rotation of the point 90 degrees to make sure that the negative 2 is over the 0. And again, the counterclockwise rotation, the 0 is over the 8 when you get this thing set up. Those are good ways to make sure you haven't done anything improper. So I get negative 2 minus y1, which is 0, over x2, which is 0, minus x1, which is 8. And notice I can check to see the negative 2 is over the 0 is over the 8. I didn't get anything improperly substituted. Negative 2 minus 0 gives me a numerator of negative 2 over negative 8. I get an m value of 1/4. Am I done because I have a slope? No. Just because I have a slope, they ask me to write the equation of the line. If they don't identify which one, we should assume y equals mx plus b. Now, I have two things that I could do. I could go back to point-slope form, take this slope, pick one point, and start cranking through it. Or I can know that y equals mx plus b is the y-intercept, and my b is negative 2. I know what my m is. I know that my b is negative 2. I should be able to directly write y equals mx plus b. 1/4 x minus 2. You could have gone back and taken the point and the slope and used point-slope form to arrive at the same place. It would take quite a while, comparatively, but you could. 8 comma 0 is my point. My slope is 1/4. Point-slope form looks like what? Oh, y minus y1 equals m times x minus x1. I'm going to plug in the x and the y. Y minus 0 equals, I'm going to plug in the m, the 1/4, and x minus my x value, which is 8. I get y equals 1/4 multiplied by the x. 1/4 of negative 8 is negative 2. Yes, did I get the same equation? I did. Did it take me longer? Yes. Why did it take me longer? Because I wasn't aware of the definition of slope and y-intercept, and I didn't clue into the idea that negative 2 could have been used as my b immediately. Would it still get me there? Yeah, it sure would. but we'd like you to get there in the most efficient way possible. Okay? Here's another situation where you've been given two ordered pairs. And when you've been given those two ordered pairs, they don't look like ordered pairs. Do you see the ordered pairs? Function notation tells you an input x, an output y. An input x, and output y. When I write the equation on the line, it will not go y equals mx plus b. It will go f of x equals mx plus b, because that's the way the information came to us. But there's my two ordered pairs. Find my slope. 6 minus 3, 2 minus negative 2. 6 minus 3 is 3, 2 minus negative 2 is 4. Does it matter whether you went 3 minus 6 and negative 2 minus 2? Not at all, because a negative divided by a negative is a positive. That's up to you. But I'm going to use point slope form now that I have slope. I had an abundance of points. I do not have a b value this time, so I don't have the option to go right to y equals mx plus b unless I want to do some back solving, which is legit as well. Okay? So you can always use point slope form when you don't have a y-intercept. I'm going to plug, and it does not matter. Let me say that again. It does not matter whether you use 2, 6 or negative 2, 3. I use my slope of 3/4. Check this time we use 0.2, 6. I plug it in there. If I use the other one, I would have y minus 3 equals 3/4. See if I can write it 3/4. Multiplied by x minus the negative 2, which is plus 2. Either one of those, both of those, if you clear your fractions and distribute, you're going to be home free to the same equation. Multiplying everything in this case by 4, we got 6 times 4, 24. We get 4y, we get 3, we get x minus 2. Erase that. Six times 4 is 24. 4 times y is 4y. The 4 is canceled out. Leave the 3 to distribute in and get 3x minus 6. Bring the 24 over. Divide by the 4. You're going to end up with 3/4 x plus 9 halves. Okay? So there's slope-intercept form. Would the same thing have happened if I used the other ordered pair? Over here, we can take a look at that. Multiply by 4, multiply by 4. You get 4y minus 12 equals 3 times x plus 2. 3x plus 6. Add your 12. Add your 12. You get 4y equals 3x plus 18. Are we in the exact same place we were a moment ago? We are. We're in the exact same spot we were. Does it matter which ordered pair we use? No. Both ordered pairs were on the line. Both ordered pairs will give you the equation on the line. You just need to work without mistake in order to make that happen. Now, we're going through all the forms because we don't know what they're going to ask you for, but the logical progression is to go from point slope to slope intercept. Okay? Once I'm at slope intercept, I'm going to clear fractions to get rid of things and go to standard form. Okay? By clearing my fractions here before I divide, I can use this form of the line in either case to rearrange into standard form if it's needed. I can take my 4y and minus my 3x equals 18. I can rearrange, get negative 3x plus 4y equals 18, and I'm not allowed to leave it with a negative, so I'll divide by negative 1 and get 3x minus 4y equals negative 18. If any of that is like, oh man, I don't remember any of that stuff. And I'm going to urge you to watch the Talk videos that I put up in YouTube at the end of this lesson from Mr. Taruf. Go through as many different versions of line issues as you might feel like you need to see, and you can get caught up to speed that way. Okay? Next thing, finding the equation of a line that is parallel. Parallel lines run at the same angles, therefore the slope from the first one will equal the slope from the second one. So, you've given me a point, I need a slope, you're telling me a slope clue, and it's related to this equation right here. I'm going to take that equation and I'm going to figure out what its slope actually is. When I get done rearranging that equation, knowing that parallel lines have the same slope, I will steal this slope. I could care less about the b value no matter what. It doesn't make a darn bit of difference to me, because clearly, if I look over here and I think about two parallel lines, they do not cross the y-axis at the same spot. So I'm not interested in this y-intercept. I am interested in this slope and this point, because if I have a slope and a point, I can write point-slope form, correct? Then I'll put the 0 in for the y, and I'll put the 2 in for the x, and I might have got excited like, hey, that's an intercept, but it's not the y-intercept, it's an x-intercept. And so I got to go through this whole process. I can't just shortcut out to the b. I get y equals negative 5, 6x plus 10 sixths. Okay? In point slope. If I'm going to change that to slope intercept, I'll get negative 5, 6x. I'll get positive 10 over 6. It should reduce to 5 over 3. Okay? Parallel lines. Parallel lines have the exact same slope. The word parallel is what we call a slope clue, so you can use point slope form. All right? Point slope form will lead you to slope intercept form. We discard the b value. There are other slope clue words like perpendicular. Perpendicular lines, if I have one line that has a negative slope, its perpendicular line will have a positive slope. They'll always intersect at right angles, and that is a result of the run becoming the rise and the rise becoming the run. So when we look at perpendicular lines, they're flipped and opposite of each other. This symbol is for perpendicular. Okay? So perpendicular is a slope clue. I have a point. I need a slope. There's a slope clue here. I need to find out what the slope of this line is that they give us. And so when we do the slope reveal, I move the 3x over, I divide by 7, I get negative 3 over 7 for my slope. But if one of them is a negative slope, we just looked at it, then the other one has to be a positive slope, or else they're not going to intersect it at right angles. And I said that they're at right angles because the run becomes a rise and the rise becomes a run. So if this is the slope from our given line, I have to flip it 7 over 3. And when I flip it, I also have to change it from a negative slope to be a positive slope. Now I can use 7/3 with the point that was given to use point slope form and write the equation in point slope form. And like we just saw, if I have point slope form, I can do all kinds of things like clear my fractions and get 3y multiply by 3, multiply by 3, and multiply by 3, get 3y minus 12 equals 7 times x plus 3. 3y minus 12 equals 7x plus 21. I can use this information to write standard form or go keep going to slope-intercept form. I'll move the 12. I'll divide by the 3. When I minus 12 from the 21, I believe I got like 9. 9 and 12 is 21, right? I'll divide by 3. And we get y equals 7/3 x plus 3. Go back and look at that. We have negative 3/7. Our new slope is positive 7/3. Seems to work out well. This is the perpendicular line that goes through that point, perpendicular to the given equation. The homework is here. I know that might have been fast. I know that might be like too slow for some of you because you know line stuff. Some of you are like, I don't remember any of the line stuff. So here's what I'm going to suggest you do. If you're struggling at all with the lines, come back to writing this information down. And I got to take this call, so hang on. All right, sorry about that break there. I know I'm not too sorry about it, but we were right in the middle of trying to describe to you where you would need to go in order to get more background on linear functions, okay? So Mr. Taru here is, you can see his username down here is Prof. Rob Bob. And I would write down linear functions, their attributes, and interpreting slope and y-intercept, Prof. Rob Bob. Okay? If you'll do that, then you'll see his description down here, and you'll see his links to graphing lines, the slope-intercept form, graphing line using x and y-intercept, standard form, slope and equations of lines and graphing, parallel and perpendicular lines, regression lines, and correlation. That is the full Algebra 1, Algebra 2 review that, depending on how much you may or may not need, you would want to take time to look at. So if you felt like, man, that point slope thing and standard form and slope and horizontal and parallel and perpendicular, all that stuff was too fast and is not enough information for you, then I would really suggest you take some time and watch some of his stuff. He's an excellent instructor who does things the way they should be done in terms of getting them off YouTube. All right, Prof. Rob Bob. I will more than likely be back tomorrow, which will be Wednesday. Right? So you'll see this Tuesday, and I should be back on Wednesday. I know that saddens some of you greatly. I understand that. But we're going to move forward with Algebra. I miss you guys. I hope that you're moving forward with it and making an honest effort. Check every problem on your homework. Get on YouTube. do everything you need to do in order to be successful, because this stuff matters. All right, I will see you when I get back. Thanks.